So yesterday we did prime factorization of numbers, and today we're going to look at how to use prime factorization to reduce fractions, okay? So we're going to reduce fractions with using prime factorization. Make sure you're writing this in your notes so that you'll be able to use it as a resource. So the first one that I'm going to come up with, I'm going to do, let's do 9 over 27. Okay? Now for this, for reducing fractions using prime factorization, you need to use prime factorization for both of your numbers. Okay? So for 9, our prime factorization would be what? 3 and 3. And once we get those 3's, we know that 3 is prime, so we're going to circle and stop. And then what?
Circle and stop.
Thank you. Circle and stop. So 9 equals 3 times 3. Okay? Now with 27, someone raise your hand, please, and give me 2 factors you know of that equal 27. Deacon.
I put my hand down because...
Okay. Anya.
9 times 3.
9 times 3. So 9 times 3. And we know 3 is a prime number, so we're going to do what?
Circle and stop.
Circle and stop. We no longer have to factor that anymore. And then 9, we see from here, it's going to be the same factorization. It's not going to change just because it's somewhere else. Okay? So now 27 equals 3 times 3 times 3. That's what we have here. And then 9 is 3 times 3. Are we together so far?
Yes.
Okay. Now, when you're reducing, what you're really doing is dividing out factors, okay? You're dividing out factors. In essence, you're making your pieces smaller or pieces larger, your number smaller, your pieces larger. So I'm going to take out this 3 and this 3. I'm dividing them out. The reason why I can divide them out is because it's the same on the top that it is on the bottom, okay? Now, I have another one that's the same number at the top and the bottom. So I have a 3 here, and I have a 3 at the bottom. I could take those out. Are there any other factors that are the same? No, there's nothing left that's the same. So at the bottom I have 3, and at the top you don't see the 1, but you put 1 there because it's 1/3. You could multiply 3 times 1 and still get 9. So it's okay and it's proper to put 1 there. Okay? Let's try another example. Let's do 6 over, let's try 48. That's a big one. The factorization for 6, 3 and 2. 3 times 2. Thank you, Cameron, for raising your hand. Cameron, why don't you give me factorization 2 numbers that multiply together to get 48?
6 and 6.
6 and something else.
6 and 6.
Nope. Chelsea.
4 and 2.
4 and 12. I like 4 and 12. 4 and 12. All right. Now, are either of those numbers prime numbers? No, neither of those are prime numbers. So, Jessica, can you give me 2 factors that you multiply together to get a product of 4? 2 and 2. I can multiply 2 times 2 to get a product of 4. Okay? So these are prime numbers, so I circle and stop. And this is another prime number, so I'm circling and stop. Gabby, can you give me 2 factors that multiply together to get a product of 12? 6 and 2. I like that. 6 and 2. We know that 2 is prime because we have it here. And we can break 6 down. We have the same information here, so we'll go 3 and 2. That's a lot of numbers. So 6 equals 3 times 2. Here and here. And then 48, we're going to have to check these because there's lots of numbers. So I'm going to put a 2 times 2 times 2 times 2 times 3. Okay? Is there something at the top that is the same as the bottom? Someone raise your hand and tell me. Sebastian.
Yes, the 2.
Okay, so there's a 2 at the top. I can take out 1, 2 from the top and then take out 1, 2 at the bottom. I'm not just getting rid of them, I'm dividing out a 2 at the top and a 2 at the bottom. Is there something else I can do? Anthony? 3. There's a 3 at the top. I'm going to divide out and a 3 at the bottom. Okay? Now, you don't have anything left to divide out at the top, so you're just going to put your 1 there. And at the bottom, you're going to multiply those numbers to get your new denominator. So now I have 2 times 2 is 4. 4 times 2 is 8. 4 times 2 is 8. Okay? So our new reduced or simplified, you'll hear it called both. So you might hear it called reduced, or you might hear it as simplified. Okay? And that's how we reduce fractions using prime factorization. Make sure that you are able to divide out the numbers if there's something the same that's at the top and the bottom, like we did here. If you don't have anything that's the same at the top and the bottom, then that fraction is at its lowest terms. Okay? For example, 7 and 13. Well, it's most simplified. This is simplified as it gets. It can't get any simpler than that for this particular fraction. Okay? And even if you had 6 and, let's see, what could we do with 6? 15, it has something in common with 15 because they both have a what in them?
3.
They both have a 3 in them. Yeah. Let's do that. Let's try that. If we break 6 down, we have a 3 and a 2. And then if we break 15 down, we have a 3 and a 5. Okay? Both of those are prime numbers. So 2 times 3 equals 6. And 3 times 5 equals 15. I can divide out a 3. I can divide out a 3. And what I have left is 2 on the top and then 5 at the bottom. So your new fraction, 6/15 reduced, is 2 and 5, 2/5. 2/5. Okay? The really important thing is you want to find factors. Now with your parents, they probably learned a different way. And I'll show you that using another video. But this is reducing fractions using prime factorization.